Hey, this is Storm Force 31 Chief Meteorologist Brad Huffines in Huntsville. I've been asked to record a little explainer about earthquakes, and in a place where we normally see hurricanes. In fact, this country saw 3 hurricanes last hurricane season alone. Let me show you what we have on Storm Force 31, our Omni Max computer graphics system. And what you're seeing in the left-hand side of your screen, of course, is the main earthquake that happened in Haiti, that area there. I'll get to that in just a minute. First, in the Gulf of Mexico and across much of the rest of the Atlantic Ocean, there's what's called the North American Plate. In plate tectonics, the Earth is made up of various plates of rock that are continually moving. In this case, the North American Plate is continually trying to slide from right to left in this direction. The Caribbean Plate, however, basically where that fault line is there, that's where the plate is. The Caribbean Plate is trying to slide to the right. So anytime any of these plates and along that fault line, they shift because there's constant pressure happening along these fault lines between these two plates, then the ground underneath can frequently shake or rattle or cause these shock waves. And that's what's happened in at least parts of western Haiti. If you also notice near San Juan over the past week, there have been several small earthquakes, which aren't necessarily uncommon, but these seem to have preceded the larger earthquake now that has happened across the southwestern parts of Haiti. As I switch you to a little bit different view of this same map, you see that each time the earthquake happens, these dots are put on by the United States Geological Survey, USGS. You can go to usgs.gov and see where all the earthquakes are around the country, and not just around the country, but around the world. There's the Caribbean Plate that you see there. When I zoom out, I want to show you how large the North American Plate is. The North American Plate is actually extends all the way across all of the United States and into the Atlantic Ocean right here, and that's where the North American Plate is, a large plate in the, again, the science called plate tectonics. Of course, the other plate, another large plate in the world, is the one that's in the Pacific, and as you may very well know, this is called the Ring of Fire. Right around the outward edge of this plate is where we have the world's largest numbers, at least, of earthquakes. If you compare what has happened in Haiti and the Dominican Republic to what's been happening in places like California, you see this large number of earthquakes that happened and has been happening in the past week along the west coast of the United States. This is not uncommon. There are daily earthquakes all around the San Andreas Fault, right there where that fault line goes through parts of Southern California and off the coast. And that's one of the reasons, again, this is called the Ring of Fire. That's normally also where you see lots of volcanic activity. Here is Alaska. There's the fault line there across the North Pacific. And again, numerous earthquakes from Alaska off through the Aleutian Islands chain and along what we call, again, that Ring of Fire, which also then extends into the Pacific Ocean. There's another small area of disturbances here in southern Hawaii, and that is the reason why we have earthquakes and the constant lava flow across the island of the large island of Hawaii. But again, check out along the, whoops, made my map go crazy there, along the Ring of Fire here in the western Pacific, numerous earthquakes as well. Then the plates really get stacked up on each other across parts of Southeast Asia, as we are seeing the earthquakes there that are a lot more common than you see in the Caribbean. Now, the reason why the Caribbean earthquakes don't happen that frequently is along this fault line, there's not a lot of movement, but you can tell in the landscape of southwestern Haiti and the southern Dominican Republic, there's lots of mountains, lots of small villages in and through here, and the largest earthquake, of course, did happen just to the southwest of Port-au-Prince. The largest earthquake was this location here. It happened about 6 miles underground, which is a relatively shallow earthquake, and that's why there is so much shaking here. Now, lastly, the thing I want to point out to you is as you see the earthquake videos around parts of the world when they happen, in this instance, this was a video taken by a cell phone user in Port-au-Prince, Haiti, of the palace shortly after it had collapsed after the earthquake occurred in the nation's capital of Port-au-Prince. It is a fairly shallow earthquake, 6.2 miles below the surface, that causes a lot of surface shaking and rippling. It's the strongest earthquake since 1860 in Haiti. Over 30 strong aftershocks as of the time I've recorded this, and I'm sure there's going to be numerous more. And it was, again, 7.0 on the Richter scale. And as a reminder, to go from 7 to 8 on the Richter scale, that's a magnitude of 10 times higher. So this Richter scale is definitely a logarithmic curve. It goes stronger and stronger stronger with each number that you rise up. That's a little bit of information about the earthquake from Haiti. As we have been seeing all the news from Haiti, it's not an uncommon place to see the earth rattling. It is an uncommon place to see these larger earthquakes, which normally don't happen along that fault line between the North American plate and the Caribbean plate. But in this instance, there was enough pressure built up, and there was enough of a slide that when that slide happened, the ripples of energy went out. And that's another reason why we are seeing the numerous aftershocks once those ripples start happening through the earth. And when I say ripples, I mean literally ripples of energy that go out from the center of where the shift was. When those ripples go out, they also then cause other cracks and fractures, and the ground begins to move and pull apart more and more until finally it calms back down and waits for that next big move. Because remember, that's what happens in plates. If you take one hand and you put another hand next to it and you push them together and then force them, eventually you're not going to have a smooth move. You're going to go like that, kind of up, down, up, down. That's what causes the earthquakes along these fault lines. Hope that helps you out a lot as far as the explanation of the earthquake along the fault line in the Caribbean and the southern Gulf of Mexico.